The output is going to be B, C, D, E, F, G, H. Now what is happening here? If you look at the for loop, what will it do exactly? What does it do? It's going to take the first character, add another character to it, add 1 to it. Now, what happens when I use an A in my system? When I'm defining a char variable which contains string, what is happening? How is the data stored in the memory? Is an A stored in a particular location? Can my processor understand A? No. ASCII value stored. So what I'm doing is I'm just adding a 1 onto that particular ASCII value, which will make it the next character. This is how the ASCII chart is organized. So if you have an ASCII chart, you can actually look at it. The next character that comes is the next alphabet. It's in the alphabetical order itself. This is how it works. So the output of this one will be B, C, D, E, F, G, H, I. Okay. Now, here what I've done is I've done a disassembly of it. Now I've used a tool known as GDB. It stands for GNU Debugger. Now this is on a Linux system. We are only concentrating on Windows system for this particular presentation, this particular workshop. But then I wanted to show that even on a Linux system, the commands are different. This is how the actual application will look like when disassembled. Okay. Now you can see all kinds of assembly language commands. So this is a very good example of assembly language. What is the first instruction?
Push EBP.
Push EBP. What exactly will it do?
Push the base pointer. Make the
base pointer.
frame.
What are the base pointer? We are pushing it into.
Will it push the content of EBP register?
Yeah.
It's going to push the content of EBP register onto the stack.
Yeah.
Okay. Let's go on to the next instruction. What is it doing?
It's pushing the stack pointer. It's popping to the.
So in this case, my EBP and SPP are they same or different?
Same.
Same.
They are same because ESP's content was pushed into or moved into EBP. Now, okay. Now let's look at the second instruction itself. It was move EBP from a ESP. Now, is it a direct addressing mode or indirect addressing mode?
Still direct addressing mode.
What is direct addressing mode?
It's not using any offset.
Let's say, okay, take a look at plus 54th command. It is add ETX, 01.
Immediate.
That is not? That's direct. When I'm pushing data directly into a particular register or moving data directly into a particular register, it becomes direct addressing mode. When I'm using a different register's content and pushing it or moving it into a different register's content, it becomes indirect addressing mode. So that is what addressing modes are. Okay. Let's take a look at the plus 10th instruction. I hope you can see that, right? It is move D word PTR. Then we have a bracket. Inside that we have ESP plus 0x0x denotes hexadecimal. 0x13 comma some number. Okay. Now if you look at the numbers, what is the number exactly?
Hexadecimal.
What are the numbers? 64, 63, 62, 61.
Maybe something.
So we are looking at the memory location 0804840E. Sorry. 0804838. Sorry, FE. Look at the plus 10th instruction. It is 0x64, 63, 62, 61. Okay. Now what is the ASCII code of A?
61. 61.
Not 41 is the ASCII code of A, right? But then in this case, I defined a different variable as a variable. So what is the string that I defined? A, B, C, D, E, F, G, H. Okay, but when I'm looking at the disassembly, it says what? 61.
Small a.
Yes, it is a small a. And what you're talking about 41 is actually capital A. Okay, so this right here is your data being defined. When you define char A is equal to something, what is happening is that during execution into a particular memory location where is it? It's placed on the stack. Okay. your variables are placed on the stack. Again, depending upon how you define your variable, it is pushed in the form of ASCII codes. This is what happens when you actually define a variable in C programming language at the machine level. Now let's take a look at the entire instruction. That part was the data type. Okay, now what is happening in the initial part? The command is move. What is the size of the data that is being passed? It's a D word. It stands for 32 bits. What does PTR stand for? Pointer. Which means that what you're looking at is a pointer variable. Okay. Now what is the data of the pointer variable? What does a bracket denote?
To the address.
So here what is happening is that when I say ESP plus 13, I have some value inside my ESP register which is going to point to the top of my stack. To that value I am adding 13. And the content of ESP register is used as a pointer. Which means whatever value is inside ESP plus 13, that particular location is where this data is to be pushed. Are you getting it? So here what is happening is that on top of my stack, somewhere around 13th byte I am placing this data. It will again depend upon how the stack is going. Whether it's going downwards or going upwards. Based on that, it will be either 61, 62, 63, 64 or 64, 63, 62 and 61. Okay. Now, what is the next instruction? Same thing. What is the difference in stack addresses?
4 bytes.
4 bytes.
4 bytes, because initially I am pushing 4 bytes. So the stack has to go up. Now again I want to define the entire string, that's why on top of it I am using another 4 bytes and placing the data. Alright. Now after that, what is happening? Byte PTR, ESP something, comma, what is being pushed?
Actually 0. None.
0 or none. This is what happens when we define a string variable. When I define a string variable, a null character has to be added on top of it, and this is how it actually works. Okay, what does jump stand for?
Move to some other point.
Jump to a particular memory location and start executing from there. What is the exact instruction? It is jump 0x and 08436. What is the location exactly? You can say the bracket.
Plus 66.
Main plus 66. Now, what is the 66 location? What is the instruction there? So move EDX something. Now is the address and this one same? Jump 8048436. Okay, and 66 it is the same memory address. So that is where it is jumping, and from there it is that execution. This is what is happening. Are you getting it?
It's the address next to the null byte.
Okay, see, jump to that particular memory location. Forget about the main plus 66 part. Jump to that particular memory location. Now, what is the code in that particular memory location?
804 and 46.
The instruction is move EPX comma same thing, right? So that is from where the next instruction is going to, next command is going to be executed. Okay, now apart from that, what is a call?
Jump to that address.
When we use call?
To pop the top of
It actually simulates the function call. To
When you want to
save
call a
the
function,
return
you use
address.
call.
Save the return address and
Yes.
push
So
EBP and all.
that is the basic difference between a jump and a call. When I'm jumping, I have to return back. Where I return back is something that I have to decide. At the same time, when I'm calling, the return address is already returned. After the function has been executed completely, it has to come back to the next instruction. That is the basic difference between a jump and a call. What does LEA stand for? Load effective address. So here what is going to happen? What will be the content of EDX register after this?
that's it. 6460 6261.
No. See here what is going to happen is that I look at the content of ESP plus 13th byte. So yes, it is going to point to my string variable. Okay, so what is the data? It is 616216. So this is what is happening. Okay, how do you pass data to a function? Functions can have parameters, and you get a return value of the function. These are two things. You get a return value, and function might require parameters. So my question is, how do you pass parameters to a function? By using stack? You just push the data onto the stack. So when a function is called, according to the function, the topmost data that you have on the stack is the parameter. If it contains more parameters, then the next data is the next parameter, and so on. Let's say my function requires 2 d-word size data. 2 d-word size data. So when the function is called, according to it, the first d-word size on the stack is the first parameter, and the next d-word size on the data on the stack is the next parameter, and this particular data is fetched and it is used as a parameter inside the function. Now once the function has been executed, where is the return value achieved? How do you get the return value?
EX.
It comes back in the AX or EX variable. Always in assembly language, when a function has been executed, the return value comes back in the EAX register. Okay? So this is how you look at the content of the registers. How many registers do I have? I have EX, ECX, EBX. You can look at it for ESP and EBP as well. Okay? ESI, ELN, EIP. Now EIP is pointing where? To the third instruction from main. As you can see, main plus 3, which means that the next instruction that is going to be executed is what? The third instruction from main. That is the reason why my ESP and EBP size are value the same, because there is a command. Second instruction will do what? It will move the value of ESP to EBP. So that's it. We have flag register, we have EIP, apart from that we have CS, ES, SS, ESFS, and so on. Ever used debug on XP or any other Windows installation apart from Windows 7? Hello? Debug is an application which is available by default on almost all Windows platforms except for I think Windows 7. So just open up a command terminal and type debug. This is the kind of output that you get. I hope it is useful. U stands for unassemble. So the first command that I issued is what? U. To the leftmost. Yeah, so it's your left, right? Towards the leftmost side of the image, what you can look at, or what you are seeing actually is the memory address and the location. Where exactly is this particular memory located? What is the segment number? 080. Again, this is entirely hexadecimal. When we are talking about disassembly or assembly language, we will be speaking entirely in hexadecimal number system. So the segment number is 080. What is the offset number? 100th offset. Okay. Actually, it's 101th offset if you look at it, but it's 100. So, now what is the instruction at that particular address?
09880.
That is the opcode. Okay, that is the opcode. And according to the opcode, the corresponding instruction turns out to be this, or and so on. Okay. So, how does a processor get opcode from instructions? My EIP is pointing to some location where the instructions are present. We will take the first 8 bytes. Now, inside the processor itself, there is a kind of table which says that if it is 08, it has to be odd. Or, for example, if you look at int 3, what is the output for int 3?
CC.
It's a CC. If you hit int 3, what is going to happen?
Interrupt.
It will get interrupted. Okay. This is how debuggers work. What happens when you set a breakpoint in a debugger?
Int 3 instruction is placed there.
Instead of that instruction, instead of the original instruction, and int 3 is placed so that, see, debugger, what it will do is it will load the application inside its own context. Okay? And in case if the